All right. All right.
There you go, Carol. You can begin.
Yeah, we're gonna go ahead now. So let's go into our little tutorial part now. Let's see if we can look at a question. So we started how we can use our trig ratios. Let's look at this question close up. Take a moment and read it. Always read through, take out your key information. So we have here the diagram that's not drawn to scale. Always look out for that because you can't use your ruler and measure things in that case. We have a diagram not drawn to scale. And it's a diagram of a triangle LMN with LN equal to 12 centimeters, NM equal to X centimeters. In other words, we don't know what it is. And angle NLM, which we're measuring, giving the measure 30 degrees. Now they tell us that the point K along LM is such that NK is perpendicular. If it's perpendicular, what does that mean? Look out for Keith. They didn't say the measure of the angle, but they tell it's perpendicular to LM. So you pull out things like that, because sometimes it may not be in your diagram. If it said it's perpendicular, then that means that angle NKM will be 90 degrees, and hence we can put in that 90-degree marker. That symbol for the 90 degrees, and tell us NK is 6 centimeters, KM is 8 centimeters. We're asked to calculate the value of X and the measure of angle theta. So we're being asked to find angle X. So Sarah is marking the two things that we need, angle X and angle theta. I mean, the length of X, the value of X for this X centimeters, excuse me, as well as the angle theta, all right? So talk to me now. How would I find? Remember we talked about, do you think it's wise to use a whole big triangle with the 3 triangles we have here? All right, so can we form right angles? Yes, we have right angles formed because we have, why do we know a right angle is formed? What's the key word in that question that told us that a right angle is formed?
Mr. Square.
No, suppose I didn't look in the wording of the question, they told that it is NK is perpendicular to LM. Good, perpendicular. So the fact that they tell us that NK is perpendicular to LM, I will know automatically that I know then that angle NKM would be 90 degrees, and also angle NKL will be 90 degrees. So it is forming 2 right angle triangles are being formed. All right?
Miss, just could you repeat what it means to be perpendicular to something, please?
Remember, perpendicular lines meet at 90 degrees. So this hand is perpendicular to this hand, almost. So it forms a 90-degree angle here.
Okay, Miss, thank you.
Okay, good. Sir has it on the screen as well. So when a vertical line meets a horizontal line, it's informed, which is why when you look at your question, they tell you that a pole standing on vertical ground, a vertical pole standing on horizontal ground. So when they use the terms vertical and horizontal, it tells you that the two things meet at 90 degrees. All right. So just to know, remember that this presentation will be on our YouTube channel. So the YouTube channel, I think we put it in the chat. We can put it again. I'll see if I can access that YouTube channel. I can tell. So some of you would like to go back over this presentation. It will always be there on YouTube for you. So just go to our YouTube channel and you'll be able to access it. So for those wanting to access the presentation, you can always go back to it on YouTube, pause as you need to, screenshot as you need to, and do all that you need to do at that point. All right? Okay, so we're trying to find, what are we trying to find here? Oh, thank you very much for posting that. Oh, Roxanne, you go, girl. Thanks for sharing with everybody. So Roxanne has shared with you for the channel. All right, so I'm trying to find the line X, the length of X. See, notice that Sir has highlighted the right triangle. I shouldn't say right, the triangle that is on the right of the two triangles. And it's always useful, students, when you're doing questions like these, is that you isolate the triangle that you're dealing with. Pull out that one and draw it by itself. So you can see all your lengths that you're dealing with, all the angles that you're dealing with. So see, we've isolated triangle NKM. We have triangle NKM, and we're trying to find the length X. What will I need to use to find X?
Mr. Pythagoras theorem.
Pythagoras' theorem, because I have two sides and I need to find a third. All right. I see somebody telling me that X will be 5.29. Look at that carefully. Could it be 5.29? Remember, your answer must be reasonable.
No, miss, because I think X is the hypotenuse and it should be the longest. So
Excellent. Good job. X is the hypotenuse. X centimeters will represent the hypotenuse. And so it must be the longest side of our triangle. All right. And by the way, as you do your questions more and more, let me just throw in a little fact. Fun math fact. Some of you are probably familiar with them. There are some things we call Pythagorean triples. They're called Pythagorean triples. And they are triangles that must be right angles. And there are some of them that you'll get to know with time. 3, 4, 5 is one. 6, 8, 10 is another. I think, what is it? Can't remember. Is it 11, 12, 13? 121, 144. No, that's not it. 5, 12, 13. Yeah, 144 and 25, 169. 5, 12, 13. Yes, I'm glad you picked up the mistake. So there are certain triangles we call triples, because you will always be sure that when you take the sum of the squares of the two, notice that I could correct myself a while ago, because square of 5 is 25, square of 12 is 144. When I add the two, I'm going to get 169. So 5, 12, 13 is another triple. Sister is putting them up for you. 5, 12, 13, 3, 4, 5, 6, 8, 10. There's another one, I think, with a, can't remember the other one, but there are others as well that you can use. All right, so always remember your hypotenuse must be the longest side. So let's look at our Pythagoras theorem. We would substitute into our theorem. 6 squared plus 8 squared will be nm squared. And we manipulate. Do I stop at the square? Nope. You must find your square root. And we're going to get the square root of 100, which is 10. So remember to be familiar with your calculators. Okay. I'm going to get nm is equal to the square root of 100, which is 10, of course, which you learned from grade 6. Even if you forgot, your calculator will help you out. So nm will be 10 centimeters. So just a little note to self, there are little triples that would be useful to know. Your 3, 4, 5, your 6, 8, 10, and your 5, 12, 13 are some common triples. All right, any questions on this one? So I have two sides and I want a third. I'll use Pythagoras' theorem. All right, great. Now the other thing they ask us to find is the angle theta. Type and let me know what I'll use to find angle theta. I'm seeing sin and I'm seeing cos, okay? Why would I say cos? All right. I see sine inverse. Good. Some people are, so I'm going to be interested in my sine ratio. Yes, because I do not have, I have a length opposite to my angle. And I have the hypotenuse. So I have opposite and hypotenuse. Which ratio has that? It's going to be sine. So it will mean that sine theta is equal to 6 divided by 12, which is what we set up here. So you set up your equation. Always use what you know to form an equation. Great. So we're finding the opposite to the angle. So then we know that that is going to be a half. And talk to me. Which angle has a sine of a half? We chatted about it for quite some time this morning. Which angle has a sine of a half? 30. And how would I find that 30 if I didn't know? I'm going to find what? Somebody, the inverse. Very good. Somebody said it earlier. I think it was not Jaden. Jonathan. Thank you, Jonathan and Danae. I'm going to find the inverse sign, and Justin, and that was going to give me 30 degrees. Excellent. Do we have any questions on that before we jump ahead of ourselves? So remember that if I'm trying to find an angle, I must use the inverse trig function. I must find the inverse trig function because the inverse trig function tells me an angle that has a certain ratio. So the angle that has a sine ratio of half would be 30 degrees. Okay? All right, so let's look at this more recent past paper question. I like this question because it has no numbers, but if you know what sine and cosine are, it does not matter at all. Let's take a moment and look at this question together. It's from January 2019, and it's part 3B. It says the diagram shows a right-angled triangle with sides A units, B units, and C units. You're to use the diagram, express C in terms of A and B. That's 1 mark. So you know that's just pure recall, what you can tell from what you know. Express C in terms of A and B. Write in terms of A, B, and C an expression for sine theta plus cos theta. And then you're going to use the results of the first part to prove this last part. So before I even go to the solution, how will I express C in terms of A and B? Talk to me. What do you know will use that information? What do you know that you could use to express C in terms of A and B? Where are the hands? Where is the typing? My chat not blowing up? How come? Why is my chat not blowing up? Talk to me. What can I use to express C in terms of A and B? Talk to me, students. Talk to me. Don't leave me out here alone, out in the cold. How could I express C? First of all, what are C, A, and B talking about? Let's talk about that. What are C, A, and B talking about? All right, I see Justin saying A squared plus B squared equals C squared. Remember to use lowercase. They didn't give an uppercase, they're going to use lowercase. What does that tell me about those 3 things? They're telling us about length. So what did you learn today tells you that you are to use length? Since they're representing lengths, I'm going to use Pythagoras' theorem. So I'm going to have A squared plus B squared equals C squared. Any questions on that? I'm only seeing Justin replying. Anyone else agrees or disagrees?
Miss, I think that probably answers my question, because I remember earlier I was asking that even when we have a angle, if we should still use the Pythagoras theorem. So now that might just be the solution, despite that we have the sign. Then yeah, because I was confused as to how you'd know which one to use even when you have the lens, but I kind of see it now.
Okay, so you're saying then, I think that was that Abriana?
Yes, miss.
So Abriana, in this case, though they've shown me a theta for the angle, they didn't ask me anything about the angle this time. They asked me about the lengths. So they've asked me to express the length C in terms of the lengths A and B. So the angle doesn't come in at all. This time they're asking me purely for a relationship between the lengths of the sides of the triangle. Are we clear?
Miss, where you see it asking you for the lengths?
Look at what the question says. A right angle triangle with sides A units, that means the length of side. The length of one side is A units, the length of another side is B units, and the length of the hypotenuse is C units. They don't tell you whether it's centimeter, meter, kilometer, doesn't matter. It's just whatever unit of length we're dealing with. So one is A units, one is B units, and one is C units. Are we clear?
Yes, miss.
All right, great. And so if I want to know express C in terms of A and B, I'm going to use Pythagoras' theorem, which is going to be as someone says, oh, you weren't sure what it meant to express C. Oh, when it says express C in terms of C, it means that they're asking to come up with an equation, come up with a relationship, come up with some equation, and you will know that since it is talking about lengths, it means that I'm going to use Pythagoras' theorem. To express C in terms of A and B, I will use Pythagoras' theorem, which will say that C squared. Now, students, even that word, sir, could you just put in, flip the B and the C for me, please? In other words, label it counterclockwise. Sorry, clockwise. So starting from A, let the hypotenuse be B. And the other leg be C. Now keep the A, but let the other one be C. Let the B be C. And keep the A. All right, students, suppose that said to me, write the relationship between A, B, and C. What would you say? What's the relationship between the lengths of A, B, and C? What would you say? Would you still say C squared equal A squared plus B squared because that's what you're used to seeing?
Miss, would it be B squared is equal to A squared plus C squared?
Correct, because it's always the square of the length of the hypotenuse. Thank you, Garrett. No, you'd have to use the relations, the lengths that are given in your triangle in order to form your relationship. Because sometimes they will have it as A as the hypotenuse, and then you'd have to change your word. You'd write your formula accordingly. Are we clear, students? So always look out for which one is the hypotenuse. Whatever letter the hypotenuse has been given, that's what you use to guide you for the Pythagoras' theorem. All right, so in this case, C squared is equal to A squared plus B squared. So we've just got now 1 mark. Yay, we got 1 mark. Let's move on. Every mark counts. Don't think it's a small feat. Every mark counts. No, they ask us to find a expression for sine theta plus cos theta. Some people say theta, some people say theta. So they ask us to find sine theta plus cos theta. I think the right pronunciation is actually theta. So sine theta, what would be sine theta, students? It's opposite, the length of the opposite over the length of the adjacent. So what letters would you use in that case? Type in the chat for me for sine theta. What would be the letters? What letter faces theta? Okay, I'm seeing A divided by C. Yes, thank you, Abrian and Danae. Anybody in agreement with that? All right, so we can agree. Go ahead then, sir. Good. A over C divided by C, A divided by C. Excellent. So that's our sine theta. We're all in agreement with that one. What about cos theta? Or cos theta? We know it can't be A over C because we just cleared that that was sine theta. So it will be cos theta, B. I'm not talking French. B. So it's B divided by C. Excellent. So they asked us for, keep your question in mind now, students. They asked us for sine theta plus cos theta. So now we're going to put the two ratios together with a plus sign. So sine theta. So students, don't let things like this throw you, you know. Sometimes people say, but I never said anything like this before. What is it? Ask me, see sec wicked, see so wicked. Use what you know and build and go little by little. Sine theta. Go ahead, Abriana.
Oh, sorry, miss. Could I see the question that we're solving, please? If you could go back.
You want to get a screenshot of it?
No, miss, I don't remember what it asked.
Take a screenshot quickly. That's it. They asked us to write in terms of A, B, and C an expression for sine theta plus cos theta.
Oh, okay, miss. Thank you.
So it would be good if you can take a screenshot, everybody, so you know what we're doing bit by bit. All right. So we're going to go now to looking at finding an expression for sine theta plus cos theta. You can go ahead, sir. Right, here we are. Since we know sine theta is A divided by C, cos theta is B divided by C, That would be sine theta plus cos theta. A over C plus B, A divided by C plus B divided by C. It's up to you. You may make it a single fraction or you may not. It's up to you. Say, what's the common denominator? Do they have a common denominator?
Yes, miss.
Which is what?
C.
And what do you do with fractions with the same denominator? You can just add the
Numerator.
Very good. So I could just make this as A plus B all divided by C. And you're done. You've just found your expression for sine theta plus cos theta. Are we clear?
Yes.
So we've just done part. So we just got 3 marks now of our question. Got one before, this is the second one. All right. Now, here's where they must say, oh my God, find this.
Miss Harris.
Yes,
I
miss.
don't know if it's my screen, but I couldn't see the denominator a while ago. Could I don't know if Mr. Lima could go back and write it beside it so I can actually see it. Because when I take the screenshot, I might forget. So Mr. Lima, could you put the or beside the expression here so I can see it a little clearer when I take my screenshot? Thank you. And we all know that the denominator is C. So just give them some time to take the screenshot or the picture of that.
All right.
Thank you.
Thank you, Mrs. Darby. All righty. So we found out our expression for relating A, B, and C. We found an expression for sine theta and cos theta. Now let's look at the exciting part. They're asking us to use, and very often CXC will do this, CSEC will do this. They'll ask you to use what you found out before to find something else. So now you're asking us to use the results from part 1A and 1B to show that the square of sine theta plus the square of cos theta is equal to 1. The square of sine theta plus the square of cos theta is equal to 1. All right. Don't let it throw you off. Take it step by step. Do we know what is sine theta? Yes. And we know what is cos theta as well. Sine theta is A divided by C. Cos theta. What happens when I square something? Talk to me. When I square something, what do I do? Anybody? Multiply by itself. All right. So somebody multiply A divided by C by itself. What will I get? How is so quiet?
Miss, A squared and C squared.
A squared and?
C squared.
A squared and C squared. Talk to me a little bit more accurately, more precise. A squared
Divided by C squared.
There you go. So I'm going to end up with A squared divided by C squared, or loosely speaking, we normally say A squared over C squared. Excellent. Thank you, Shante. What about cosine, the square of cosine theta? What would I get that time with that one? Using the same idea that Shante just used. Using that same idea, what would be the square of cos theta? Talk to me, man. Don't let me, I don't like being alone, you know. What would I get? So they're asking us to use 1A and 1B. 1A was that C squared is equal to A squared plus B squared. And 1B was saying that sine theta plus cos theta equals B divided by C. All right, so we have our cos squared, square of cos theta is B squared over C squared. Great. Pardon me, I'm seeing that coming up in the chat. Great. So now let us use our sine, the square of sine theta, which is A squared over B squared. So Sarah, can just come to the next line, please. So they've asked me to show that, they're asking me to show something. So when CXC asks you to show something, it means that you're going to use what you did have previously and work down till you get to what they've asked you. So we know that the square of sine theta plus the square of cos theta will be what is on the right. A squared over c squared plus b squared over c squared. All right, fine. Great. So that's what it's gonna look like, which is what you all told me a while ago. So we're on the same page. All right, but remember we talked about fractions with the same denominator. I just add the numerators. So that means I can write this then as a squared plus b squared. Talk to me again. What would be the next thing you would do? Since they've told me that c squared is a squared plus b squared, then I'm gonna just simplify. My goodness, isn't it just an hour I'm supposed to have with you? Did I go over time, Mrs. Fenton?
Your time is over, so we're just going to ask for an
we're going to ask for. I just realized we've gone over. So can you
additional 10 minutes?
A few more minutes, please. Yeah, we'll just probably do this now.
If you're good, we hope we're not inconveniencing you
in any way. I didn't even realize that it had gone so far. So I do apologize for that.
So we'll finish by 2:25.
Somewhere okay? There, yeah. Just let us know in the chat if that's okay with you, please.
Finish up the questions and then.
So can finish up the questions and send you on the merry way. And remember, you can access all this on our YouTube channel. So if you didn't get something this time, you can always go to the channel and review it and cement it for yourself a little better. All right, I see some yes, miss, and okay, miss. Thank you for that. No.
Sorry, Carol. As Miss said a while ago, we know that this presentation may not be the pace at which you would like to go, but as Miss Harris just said, you can go and slow it down, stop, work it out, and work at your pace if needs be. Or you can refer your friends and family to the page, and they can get some insight on the content. All right, sorry, go ahead, Carol.
Okay, sure. So let's look at this now. So we know that c squared is equal to a squared plus b squared. So what happens when I substitute for c squared now? I'm going to end up with what? A squared plus b squared divided by what? A squared plus b squared. Talk to me, man. Right.
A squared, yeah.
Because c squared is a squared plus b squared. When I divide something by itself, what do I get?
1.
1. So we just answered their question.
And hold on, miss. My eyes are dazzling. Wait there.
Where so much A, B, and C come from?
So, miss, because the c squared, I think, yeah. My head not so tough, but it's tough when it's ready, I think I get it still.
So you see that since c squared is a squared plus b squared, which is what we found out from Pythagoras' theorem. All right. We can now fill in or substitute that c squared into our equation for the sine theta squared plus, the square of sine theta plus the square of cos theta. All right, so I'm adding the square of sine theta to the square of cos theta. Don't say sine theta squared because I'm not finding the square of the, I'm not finding the sine of the squared angle. I'm finding the square of the sine. Just as an aside, be careful with your language. So I'd have to say the square of sine theta because I'm finding the sine of theta, then I'm squaring it. I don't say sine theta squared because I'm not finding theta, squaring it, and then finding the sine. So be careful of your language. Just thought I'd tuck that in there. Hopefully I didn't confuse, but it's just very important that you make that, you be clear on that, all right? Ah, good question. Could I have substituted c squared on the numerator instead of c? Oh, you could because since I know a squared plus b squared is also c squared, I could have put the c squared. Thank you for this question, Karima. So I could put the c squared. Did anybody else see that? So the question is being asked, since I know c squared is equal to a squared plus b squared, could I have put the c squared in the numerator? And you certainly could have. So I could have said c squared divided by c squared, which would also be equal to 1. Thank you for that one, Miss Karima. Mrs. Mundell Thomas, thank you, my colleague and student in one. Are we clear on that, everyone?
Yes, miss.
Great. So don't let letters throw you off. But the maths, no, our maths exam, we know where so much letter come from. No, just take it step by step using what you know. All right? Okay. Let's take one more. Which one else came after this again? Was it elevation and depression? All right, let's look at this other one. Also from January 2019. Wow, it's like Olivia and her lighthouse. So a person at the top of a lighthouse, TB, the lighthouse is represented by TB, sees two ships, ship 1 represented by S1 and ship 2 represented by S2, approaching the coast as illustrated in a diagram shown. The angles of depression are 12 degrees and 20 degrees respectively. So the angle of depression to ship 1 I'm just looking at something. I probably copied that down. Anyway, the angles of depression are shown. So we are asked to put in the angles of depression. Complete the diagram below by inserting the angles of depression and the distance between the ships. Okay. So the angles of depression, I don't know if that respectively should be there. Anyway, I probably typed that off incorrectly, but let's look at it closely. Yes, Abriana, is your hand up for a question?
Miss, I was going to answer.
Let's hear you. Go ahead.
Okay, miss. So the angle of, well, miss, for ship 1, it would be the 20 degrees, and for ship 2, it would be the 12 degrees, because ship 2 is the furthest, and so you're not really miss, I don't know how to phrase it correctly, but it's, yeah, hopefully, yeah, something like that. Yes, Danny, exactly. Versus ship 1, you're tilting a bit more, so that means that ship 1 would be the 20 degrees.
Okay. And where should I put my 20 degrees based on the question? Should I put it at the S1 or up near the T? Where should I put it based on the question? Where would I put in that angle of depression?
That is a very good question. Miss, I'm thinking.
Go ahead. Anybody wants to think with her or say their thoughts out aloud? Sir, I wonder if it's I wonder if I should put it at S1TB. I wonder if it's there I should put it, S1TB. Put it there, let me see, sir. Let me see if the 20 can go right there. Could it be there? Could I put the 20 at...
Oh, could you repeat that one from, please?
Could I put the 20 at S1TB? Could I put it right on that in here? So I'm trying, well, not that one. The other part, yeah. Could I put it right there? Not there. Come over to the B, come over to the TB, you know. As a matter of fact, could I use that? Could that be the angle of depression? Could it be from the line T to S1? All right. T to S1, let's see that one. Could that be the angle of depression for, which one would that be the angle of depression for? Anyone? Sir, could you put not that one, sir, not the R, and let me have a green one going from S1 to TB. TS1 to TB. Another color going from any color, any other color. No, not there, from TS1 to TB. Because I find sometimes our students take that as an angle of elevation. No, TS1 to TB. In other words, that upper R right there at angle T, come now to TB. Make a, right, that arc. Which of those is the angle of depression? Is it the green angle, the red angle, the amber angle, or the black one?
Is it that you're saying there's only one angle of depression?
Oh no, which of those are angles of depression? Thanks for that, Mrs. Denton. Mrs. Fenton. Which of those?
Guys, remember when we're doing angle of the depression and elevation, we try to recognize, to identify the horizontal. Above the horizontal is one, and below the horizontal is another.
So would my green angle come in at all? Talk to me.
Open your mic, guys. Tell us what you're seeing.
No green. Why not? Why is it I couldn't use the green? Is it anywhere with my horizontal? No, it's not. Right. So I would not use that green. I asked because over the years I've seen my students identify angle of depression there, and it can never be there. As Mrs. Fenton said, it must be an angle of depression will be below your horizontal. So you always measure your angles of elevation and depression measured from the horizontal. So I see that the black line is for 20. Okay, that arc is for the 20 degree, and the red is for the 12. All right, anybody?
Yes, miss, I am lost in terms of the labeling. Because the yellow and the green, like, could you just fully
Yellow
explain?
and the green are often errors that children make, and want to make sure none of you come away with that error. So sir, you can take out the green and the amber so that they don't get confused. Never make those mistakes. I'm only showing what I don't want you to do. What teachers call a non-example. Don't you ever put those as your depression. Are you clear, Abriano?
Yes, miss. So the 20. Okay, I'm still trying to get how we drew. Yes, sir. Thank you very much.
That's our horizontal.
Yes, miss. And then you're looking down.
Mm-hmm. And the bigger down is for the nearer object.
Your head would have to, the person would have to tilt or look further down to see the object closer. Just as if you're standing up looking at a cat who is a little distance from you versus looking at your toes. So the nearer the object is, the larger the angle of depression. The further the object away from you, the smaller the angle of depression. So once you identify your horizontal, which is denoted by the dotted line, which we just labeled full black right there, you would realize that your depression, your angle of depression would exist below the horizontal to the object. So you have S1 and you to the ship is ship, yes, to S1 and S2. So you have two angles of depression. Which is the furthest ship?
Repeat your question, miss.
Which of the ship is further away from the lighthouse?
Oh, miss, S2.
S2. So you're expecting, if you're looking at something further away from you, the angle of depression would be more or less, greater or less?
Less, miss.
Less. So hence why you have that 12 degree, which is touching the line that is labeled S2. You see that?
Oh, yes, miss. So it's from the horizontal line to
the line of sight.
Yes, the object.
I see it now. Okay.
Right. All right.
Okay. I hear that. I see it now, and I love to hear that. Is everyone seeing it? So I'm gonna label from the horizontal to TS2 and to TS1. So those line segments. So that's where you would label. Where would all 110 meters be put? Does this remind you of anything that we discussed earlier, by the way? Does this remind us of Olivia and our lighthouse at all?
Yes, Miss.
Okay. And so our question to you is, where would I put the 110 meters? We've shown where the 12 and the 20 are. Where would you put the 110?
Miss TB.
You'd say TB? Where did they say 110 was? The ships are 110 meters apart. Does TB represent how far the ships are apart?
Oh, no, Miss.
Okay, because TB, they said, is the lighthouse. First, at the top of a lighthouse, TB. So TB represents the lighthouse. So the ships are 110 meters apart. Where would I put that 110? I see Jonathan saying between S1 and S2.
It's between S1 and S2.
Okay, thanks, Shanice and Jonathan. Deshaun is also saying that. Thank you. So, sir, we can do our review then. All right, so that's what your diagram would look like. Okay. Now, suppose they told me that ship 2 is 271 meters from the lighthouse. And I want to now find the height of the lighthouse. Could you do that? Could I find the height of the lighthouse using this information? Okay, Danae, how would I use it? Because we're about to wrap up. Okay, I see Danae saying I'd use a sine ratio because I've been given an angle. I'm being asked to find the side opposite to the angle. And I would then, could I use Deshaun? Look again and see if I could use cosine. Okay, so Danae is typing in the chat that she says that sine of 12 will be equal to TB, which is X, which we don't know, divided by 271. Deshaun, I couldn't use cos because I have not been given BS1. I don't know the length of the adjacent side. Okay, Deshaun, so I couldn't use cos. I'd have to use sine because I'm given the side opposite as well as the hypotenuse. And then I would substitute and I would manipulate my equation to allow me to get the length TB. And similar to what Miss did in our presentation earlier on, I would multiply both sides by 271 and I would obtain TB as being equal to, I think, 50 something meters or 70 something, yeah, 50 something meters, 1/5 of that. 1/5, yeah, 50 something meters. There you go. All right. So these are some ways you would use your trig ratios to answer CSEC questions. We've tried to take real questions so that you can get real examples. All right. Are there any questions? We're going to wrap up here because we've passed our 25 minutes that we said we would ask you for. Do you have any questions at all before we wrap up? Yes, Deshaun, 56 meters is correct. We want to thank you for joining us today. We have fewer than we had this month, but we appreciate your coming out. We will have some more workshops hopefully later on in the year. Look out for it, but more than anything else, revise, revise, revise. Go to the YouTube channel. Please fill out the evaluation form for this tutorial section for the afternoon session.